Dear student, in today's lecture, we will discuss about routing in mobile computing. As you can see, there is an environment of battlefield in which we have soldiers, we have tanks, we have other vehicles, military vehicles. We also have the headquarter, or you can say the base station given over here in this region. Then onward, we have the drones, which are also used for some attack purposes, and they are also communicating with other vehicles. Similarly, we have the satellite given over here that provide the necessary infrastructure for this communication as well. So there can be a communication among these soldier as well as among these vehicle and soldier and the satellite and the drone. Similarly, all these nodes are also in the communication with the headquarter or with the base station. So it is very necessary to know that how the route is established from headquarter to these soldiers, how data or information is delivered, and similarly, for example, if any information is sensed by these vehicles, by these soldiers, then how it can be provided or transferred or transmitted to the base station or other nodes of the same interest. So here are the outlines of this lecture. We will have the introduction, then we will have discussion on different types of routing, such as unicast routing, multicast routing, geocast routing, broadcast routing, and anycast routing. And let me explain it a little bit here about these routing techniques. For example, the first one is unicast routing, in which a single node is involved, and this is a uni or a single or a node to node communication. So in unicast routing, you can see that we have a single node, and that is communicating with the other node. So this is node A, and here is node B, and they can communicate with one another. Node A sending data to node B, and node B sending data to node A. So they are sharing information with one another, and this is the node to node or single node communication. So as you know that uni stands for one. Uni stands for one. So this is a communication between one node and another node. Now, another type of routing is multicast routing. And in multicast routing, we have one-to-many communication. This is multicast routing, and this is one-to-many communication. So there is one node, a single node, node A, and it is communicating with a group of node. This is a group of node. For example, there may be some other nodes. This is node 1, 2, 3, 4, 5, and 6. Node 6. So out of these 6 nodes, the node A is communicating with these 3 node 1, 2, 3. So this is a communication with a group of people who has a common interest. Our group of nodes, you can say a group of nodes having same interest. So this is a multicast. Next one is the broadcast communication. And broadcast routing is that you are delivering data to all nodes in the network. For example, Here, if we can consider the same scenario, then we have node 1, we have node 2, we have node 3, we have node 4, similarly 5, and then onward node 6. So it means that node A is communicating with all these nodes 1, 2, 3, 4, 5, and 6. So communication with all nodes are data delivery to all nodes in a network. This is called broadcast communication, in which all nodes are involved. There is no group actually of the same interest. You want to deliver your data to all, and that's why you can say you can see that we have the radio broadcast station, radio broadcast. Or sometimes there may be some channels, TV channels, which are broadcast and freely available. Some TV channels may be available on specialized subscription, and you can include them in multicast. But here, the TV channels which are freely available to all nodes, then that is considered as broadcast. Another type of routing is geocast routing. And as you know, that this type of routing is specifically based on your geolocation. What is your geographic location with respect to other nodes? For example, we have a node A again here, and it has a specialized zone or area, and you can say that all nodes that come inside this particular area will receive this information. For example, this area is, you can say 10 meter, or you can say 1 kilometer. So all nodes inside that particular area or region or geolocation will receive information. So this is specifically based on geography of these nodes, where a node reside. And based on that, it will receive or it will get information from the source node. Another important routing is Anycast routing, and in which anyone or any node inside a network may receive data, and then it means that the job is done. He will further deliver if required to other nodes. So we have the same scenario in anyone out of this network may receive this information, and it means that the task is satisfied. So anyone in the network can receive this data. So this is Anycast, and I hope this will be clear now. Let's move towards the lecture. So here we had discussion about unicast routing, multicast routing, geocast routing, broadcast, and Anycast routing. So here the first important thing is that how mobile nodes or mobile networks are different. Actually, there is one type of mobile ad hoc network, which is a network without any infrastructure. We had already discussion a little bit about it. That's why you can see here that these networks are formed by wireless hosts, which are mobile or which may be mobile. And there is no infrastructure for these nodes, and route between these nodes may potentially contain multiple hosts. It means that they can take help from multiple nodes to deliver data from source to destination. Here you can see that as the nodes are deployed somewhere, then they communicate with one another, and you can see the circle that every node have their own zone for communication, and based on that they can share information with one another, and then they can make a topology. Therefore, there may need to traverse multiple links to reach a destination. You can see we have this topology after this communication, and there is possibility that the nodes may move from one location to another location. Over here, mobility causes route changes, and that's why when the nodes move from one location to another location, then they reinitiated this process of sharing information, sharing their location with one another, and then establish a new topology, which is visible over here. And these nodes are connected with one another, but there is no duplicate connection as we have in the last topology. Why we prefer these ad hoc networks? The first important thing is that they are easy to deploy, and similarly, the speed of deployment is higher as compared to some infrastructure. Similarly, there is no dependency on infrastructure, therefore, the deployment is much easier. And another important thing is the cost that can be considered as one of the most important parameter is the cost is lower, so therefore it is considered as one of the best option for emergency network deployment. There are some variations which may exist inside these network, and one important thing is the capability of these nodes. For example, if we have a fully symmetric environment, then all nodes have identical capabilities and responsibilities. And you can see here that, for example, if we have a node here in this network, and that is a symmetric environment, as we discussed here, this is a fully symmetric environment, then the nodes can have this is a symmetric environment. So here it means that a nodes have same capabilities and a responsibility. So look at this, the capabilities may be the transmission power, the reception power, the memory of these nodes, the processing or computational power, you can say, and similarly the mobility. While other responsibility of these node is that the node may act like a client, the node may act like a server, it can act like a router or forwarding nodes. And it can also play the role of a group leader, or you can say the cluster head or group leader. So these can be some responsibility. And for example, if a node have all these same capabilities, responsibilities, and the responsibilities and capabilities, then definitely you can assign them based on their capabilities. Because you know that as time passes, the energy of the node goes down, and similarly, the other nodes have higher energies, so you can assign them some additional tasks or some additional duties as well. Another important thing is asymmetric capabilities, and you can say that here some nodes are more powerful They have more energy, they have more transmission power and range, and similarly, they can also have longer battery life and the processing capabilities. And therefore, the mobility pattern or the mobility speed of these nodes may vary from time to time. So based on these asymmetric capabilities, we can also give them some additional role, as we discussed about the cluster head or group leader that can be assigned to these particular nodes, and they are totally based on their capabilities, their movement, their capability to move, change the location, their speed. For example, here you can say that is asymmetric, and we have two different nodes and they have different capabilities. So as the capabilities are different, so similarly, based on their capability, you can assign them this different responsibilities. You can assign them different responsibilities or different role. As we discussed, that the node with higher power for transmission, for reception, for computation, more speed, and similarly some other important parameter, then this node can be a cluster head or a group leader. So these are actually the additional responsibility that you are assigning it based on its capability. So you may not assign these responsibility to every node, but to those nodes which are more powerful and they have the capabilities to play that important role inside a network. Similarly, there may be some traffic variations. For example, you have different types of traffic pattern in these networks. For example, data are sharing through bit rate or byte rate, more data are shared or low data are shared. Similarly, the time constraint for some communication model, that it is important to deliver this data before this time, otherwise it will be useless. Similarly, reliability requirement between these nodes, which one is more reliable and trustworthy. Look at this, the trust is also a very important parameter among these nodes, that either you should be able to trust every node, or you may have some verification pattern based on which you can trust these nodes or not. Then the capabilities of these nodes to do certain type of routing mechanism. Either they will work with unicast, multicast, or geocast, as we discussed, and what sort of addressing they will use for their communication pattern. Either it will be a host-based addressing, content-based addressing, or capability-based addressing. There may be a possibility that these nodes may work with within a hybrid environment where sometime the infrastructure may be present at one side and other side is totally without any infrastructure in ad hoc pattern. Another important characteristic is the mobility pattern, that what is the speed of these nodes, and then the prediction or the direction of mobility or the pattern of mobility of these nodes. In a uniform network, as you know about that, we have the capability that nodes move with the same speed, and there is very or even very low differences between these nodes. So, for example, what is the mobility pattern? mobility pattern of these nodes. For example, if we have this network area and we have a node here, so either this node is moving directly in XYZ plane, this is Y plane, and this is X plane. This is either the node is moving in X plane only, the node is moving in Y plane only. The node is moving in zigzag path, and there may be a possibility of pastime. You can add some pastime where the node will stay for a certain period, and then onward the other node can deliver data to that particular node. So here is the pastime. So either that will be a direct movement without any pastime, without any pastime. So this is very important, that what kind of mobility pattern you are following. Or you are moving in a particular location, stay here for some time, then you are moving here, and then onward you are moving to this position, and then you are moving to the initial position, which was actually 0. So there are different types of mobility pattern followed by these nodes, and based on these patterns, sometimes the network moves up, and sometime it may move down. Similarly, uniformity or lack of mobility characteristic among different nodes may affect the performance of these computer or these nodes. One important thing about the deployment of these nodes can be that what sort of deployment we can have in these networks. So the node deployment, either we have a uniform deployment or we have a random deployment. So for example, if we have a uniform deployment, then all nodes will deploy on equal distance from each other, and this is considered as a very controlled environment. For example, we have these nodes, node A, B, C, D, E, F, G, H, I, J, K, L. We have these nodes, and they are deployed here in this particular area in a uniform way. And random deployment can be like this. We have A, B, C, and even D together. And then onward here we have E, F, J. Here we have H, I, J. So this is G, and then onward K, and then onward L. So this is a random deployment where you don't know about which node will lies at which location. So here are some challenges for these particular nodes. They have limited wireless range. Similarly, their broadcast nature may create about hidden terminal problem or exposed terminal problem. Sometimes there may be the packet or data loss due to continuous mobility. You may have sometimes the mobility, controlled mobility, or mobility induced changes may create some extra problem that includes the packet loss, that include the battery drainage very fast, and similarly there can be some partitioning as well inside the network, that you may be connected earlier, just 2 minutes back you are connected with some node, then they move from that particular location and now you are in a new neighborhood. Similarly, there is ease of snooping on wireless transmission as well. Security by itself is considered as a threat for these wireless network, and it is very important to know that these network actually work on a broadcast mechanism. Therefore, their data is mostly exposed to external users or to attacker, and that's why they may attract the attacker's attentions. Here are some important parameters about the research on mobile network, and you can see that we have variation in capabilities and responsibility of these nodes. Similarly, variation in traffic pattern, traffic characteristic, and mobility pattern. Similarly, the performance criteria may vary based on the administrative structure of these nodes as well as the mobility pattern of these nodes. For example, what will be the optimized throughput and energy consumption of these nodes, and how we could be able to reduce the energy consumption inside these nodes. So because of these flaws, or you can say because of these built-in problems in these networks or in these mobile computing, we have a very good opportunity that we can get the research funding. So there is possibility that you can explore any good research area, and then onward you can get funding from that. Why is routing in mobile ad hoc network different? And there are some important things. The first one is the mobility by itself. As the nodes are mobile, they move from one location to another location. Therefore, there is continuous link failure and repair due to mobility, and they may have a new neighborhood after a particular time period. Similarly, the link failure and repair by itself is very high. Therefore, the nodes are always in the attention mode, that they can be active to find or to discover the new routes toward the destination node. Therefore, some more performance parameter that can be used for this particular type of network, that is the route stability despite mobility, that how much your route is stable instead of your mobility, that you are moving and you are changing your positions continuously. Another important parameter can be the energy consumption, that how fast you consume your energy, or you can say that how fast your battery drains. So as much you can prolong this drainage and this energy consumption of a node, it will play a very vital role in the network lifetime. So now moving toward unicast routing protocol. And as you know about that, there are many protocols proposed by the researcher for routing and for communication in these network. Some of them may be invented, adopted from the already existing protocols in traditional that exist in the traditional network. But there are also a few protocols that are particularly designed for these mobile networks. Though we can say that there is still no single protocol which is considered as the best protocol in all environment. So it depends, remember, it depends on the network environment, it depends on the mobility pattern, it depends on the asymmetric or symmetric capabilities and responsibilities of the node. But there is need of designing some good protocol that should be adaptive as per the given scenario or as per the dynamic scenario of these networks. So therefore, some attempts were made to develop an adaptive protocol for these networks. Now, look at the categories of these routing protocol, and that is totally based on their characteristic. We have proactive protocol, which determines a route independent of traffic pattern. Traditional link state and distance vector routing protocols are actually proactive. So in proactive protocol, we actually save information about route, save information about the neighborhood node, and we maintain these information just like the traditional distance vector and link state routing protocol, that a routing table is maintained on every node, and they know about that which node is on their right side, on left side, or up and down. Another important type is reactive protocol, which is clear from its name that this is a reactive protocol, and it maintains route whenever there is need for communication. If there is no need, then they will delete these routes. Once there is need for data delivery, for communication, and for transmission between or among different nodes, then they will start the route discovery process, and then onward, the data will be delivered to the desired destination. Next one is the hybrid protocol, which has characteristic of both reactive and proactive protocol. So these protocols, hybrid protocols, are actually the adaptive protocol. And this is now the new trend which is going on, that the protocol should be an intelligent protocol, and it must uh, adopt itself as per given requirement. If the requirement is, if the network is stable, it's not that much dynamic, then it is better to have the proactive protocol. So the behavior of the hybrid protocol will be proactive. But for example, if the network is more dynamic, there is continuous change of route or link breakage because of the mobility of certain nodes inside the network, then a reactive protocol is considered as a good option. So it can move here and there based on their requirement. There are certain trade-off. The first one is latency of route discovery. As we discussed earlier, that there may be some delay in route discovery while nodes are mobile and they are continuously changing their position. In proactive protocol, as you know, that we have data already saved in the routing tables. So therefore, it has lower latency since routes are maintained at all the time. While in a reactive protocol, we don't have any routing table. So therefore, it also depends on the position of a destination node. If it is closer to the source node, then we will definitely discover it as soon as possible. That if it's means on long distance from the source node, then it will take more time. Therefore, there are a higher delay in reactive protocols, and the main reason behind that is that route from X node to Y, which is source and destination, will be found only when X attempt to send to Y. So, for example, if there is no communication, there is no route, there is no table maintenance, just like proactive protocol. Now, if the next trade-off is overhead of the route discovery and route maintenance. In reactive protocol, we have low overhead because we only discover the route once it is needed. There is no extra cost of route maintenance. Similarly, storage of a route in the routing table, and similarly, no complex computation to get multiple best option and then consider and save the best route in the routing table. While proactive protocols have a high overhead, but not necessary every time, as I told you that it also depends on the network topology. But most of the time, as it maintained a routing table and information about its neighborhood nodes, so the overhead is a bit higher. So therefore, they are continuously looking at the neighborhood. If there is any change, then they do the same updates in their routing table. If they don't do that, then they will have the stale cache problem, in which they have outdated information, which may be dangerous sometime for the destination and source node. The stale cache, the stale information inside the table may misguide the complete network, not only a single host. So it also depends that which approach achieve a better trade-off depends on the traffic and mobility pattern. And that's what I told you earlier, that the topology, the administrative structure, the mobility model followed in that specific network is also important to know about the overhead. Now, moving particularly to the unicast protocols, normally the older concept that was used to deliver data from source to destination was flooding, and that was extensive flooding. You are sending the same packet again and again, and it is responsibility of the nodes that they should ensure delivery of that packet to the destination node. So in flooding mechanism, the sender S broadcast data packet P to all its neighbor, and then onward, every node receiving packet P will forward packet P to its neighbor. So sometimes there may be a duplication of these packets, but this is very important that we have the sequence number in these packets or in this frame, based on which the node can identify that either he has received and processed that frame earlier or not. So sequence number are used to avoid the possibility of forwarding the same packet again and again or more than once. So sequence number is very important to know the duplication of this data, and therefore you can initially drop the packet at first. Packet P reaches the destination D, provided that D is reachable from sender S. So once packet P reach the destination node D, then it means that source can deliver data to the destination node. Node D doesn't forward that packet to any other node, or you can say to its neighbor node, as the other nodes are doing so, that they are forwarding the packet P to their neighbors. Here you can see in this diagram, we have multiple nodes. We have, this is the source node, and we have in the neighborhood nodes, we have node B, C, D, E, F, J, K, and so on. Here the destination node D lies over here, and the source node is represented by a blue color, which means that has a node that will send data, or the blue color will be given to a node that will receive that packet P. Similarly, this line represents that these nodes are connected with one another, and they can communicate easily or directly with one another. They are in transmission range of one another. Now you can have a look to the flooding mechanism that start with the broadcast by sources, and initially sources send this data to B, C, and E, and as the data is received by these three nodes, then they will definitely check that either it is the first packet they have received by the sequence number, or they already have received or processed this data. So this red arrow now represents the transmission of packet P toward the neighborhood node. Now, the BC nodes and E node actually receive data from S, and now it is their responsibility to flood this data to the next node. Now, if you can see, BC are forwarding their data to their neighborhood nodes, in which E send data to C and F, C send data to H and G and E, and B send data to A and H. So if we have a look at node H, so node H receive this data or packet from two neighbors. He is also receiving from node V and node C. So there is a potential of collision that the packets sent by V and C are received at the same time to node H on its reception antenna, and there may be some collision and node H may not receive anything. Similarly, if we have a look, C and E are receiving the same packet which was received earlier from S, and that's why, based on the sequence number, they will drop this packet. Then onward, node G and F also receive this data. Now, if moving toward the right side where the destination node is, F and G are sharing the same packet. Similarly, G and H both are transmitting the same packet to node I, and there is possibility of collision over here. JK also receive the same packet from F and G, though F and G are creating redundancy by sharing the same packet, which may be resolved based on the sequence number. So node C receive packet P from G and H. Here is node C. So he is receiving the same packet from node G and H, but it doesn't forward it again because node C has already forwarded node P once. So this is now the intelligent approach followed by node C, that it doesn't forward this packet node P to its neighbors, as it's already processed or sent or shared this data with the other nodes or its neighbor. Now we have data on node J and K. Is the destination is toward right side, therefore we will more focused on the right side. So node J and K both broadcast their data packet P to node D, and we should keep in mind that there can be a possibility of collision because of the hidden terminal problem. As you know that J and K both are hidden from each other, therefore there is possibility that the transmission may collide at node D. A packet P may not be delivered to node D at all despite the use of flooding. And on this side, it is moving toward node M and L. And over here, for example, if there is no collision, node D will absorb this packet and it will not be forwarded to node N. There are two more nodes, Y and S, in this network. And as you know, that they are not in the range of any node. Therefore, because of this, they are not part of this communication process. So node D doesn't forward the packet P because node D is the intended destination of packet P. As node D is the intended destination, so it absorbs the data and will further process it, and then N receive nothing. Similarly, M forwarded to L, and then it will broadcast back to M. As M has already forwarded the same packet or processed the same packet having the same sequence number, so it will stop over there. So now the flooding is completed. Nodes unreachable from S doesn't receive packet P, as we discussed about Z and Y, that they are unreachable, they are not in range of these nodes, so therefore they will not receive any packet. Nodes for which all paths from S go through the destination node D also don't receive any packet P, and in that case we have node N. As the path to node N is passing through node D, which is the intended destination for this communication or for this pattern of packet delivery. So therefore, D will absorb the packet and it will not pass to the node N. So there is possibility that the flooding may deliver packets to too many nodes, which is the worst case scenario in this situation. All nodes reachable from sender S may receive the packets, and you can see that all those packets, even 95% of the network is now blue, which means that they receive this packet. And this packet was only distance to node D. So the intelligent approach would be to avoid all those nodes which are not part of this communication process, which are not part of the link, which have no interest in this data, should not receive this information. So here are some advantages of flooding. The first one is that flooding is a bit simple. You haven't any specific responsibility. You just flood, and every node which is responsible or part of that network will flood and shared with its neighbor, and his neighbor will further do the same, and at one point you will find the destination node. They are maybe more efficient than other protocol when rate of information transmission is low enough that the overhead of explicit route discovery or maintenance anchored by other protocol is relatively high. So look at this, the route discovery by itself may sometimes be a complex problem. And in this flooding mechanism, you find some route by hook or by crooks through some indirect nodes or indirect relationship to find the destination node. This scenario may occur, for instance, when node transmits small packets relatively infrequently, and many topology changes occur between consecutive packet transmission. So whenever there is consecutive packet transmission, if the node is not there, then you have to start the route discovery process again and again. And there is possibility that you want to deliver three packets, and for all these three packets, you have done the route discovery toward the potential destination. So potentially higher reliability of data delivery through this flooding mechanism, because it exploits all the possibility, it share the data with all nodes. And the main reason behind that is that packets may be delivered to the destination on multiple paths. Another issue over here may be the issue of redundancy, that you are delivering the same packet, the same data to destination node multiple times. Some disadvantages of the flooding. For example, the first one is there can be very high overhead because the data packets may be delivered to too many nodes who don't need to receive them. And as I told you earlier, that almost 80% or 90% nodes are receiving the same data, though it is not of their interest. Similarly, potentially low reliability of data delivery because of the broadcast mechanism. As flooding uses broadcast, therefore, it is hard to implement reliable broadcast delivery without significant increase in overhead. So it will also increase the overhead, and there may be a possibility of a collision when everyone is transmitting the data packets or the same packets to a destination node. So a lot of traffic comes on the network links. So the possibility of collision between two packets, which may particularly between the neighborhood of the destination node, in which J and K nodes were involved when they transmit the data to node D simultaneously, then there is possibility of collision, which will result in the loss of packet. So here another important thing is that instead of sending all data, we should flood the control packet. And this control packet have no information, but only the source and destination. That node A or node B want to deliver data to node D. So there are many protocols which perform limited flooding of control packet instead of data packet. You are not sharing everything, but you are only sharing the control information. The control packets are used to discover the routes, and once the route is discovered, then the data is delivered toward the destination node. So first discovered routes, and these routes are subsequently used to send data packet to the destination node. Overhead of control packet flooding is amortized over data packet, and transmit it between consecutive control packets flood. So this is very important to know that sharing all those information, exposing your data to all users of the network, it is really important that only focus on the control data, transfer control information or data to the destination node. And when the destination reply back, then you can deliver the desired data to the destination node. So and next is the DSR protocol. I think we will discuss this in next class. We had already discussion about flooding and about the routing protocol. So if you have any question, you can ask. Thank you so much.